The carbon age begins a 3-hour drive from Seattle, deep within a semi-arid desert in the far northwest of the USA. This was and is pioneer country. Today it is the pioneer setting for an industrial revolution. There must be a good reason for a carbon specialist like plant manager Steve Swanson to work out here.
I moved to Moses Lake in mid-2010 with the objective of building and managing the best carbon fiber plant in the world. I really have a personal objective and a mission to make absolute sure that we are very successful and our project will change the future for carbon fiber in the automobile industry.
The plant that was opened in 2011 is a joint venture of BMW and SGL Carbon. Carbon fiber is produced at this factory. The material automobiles will be made of in the future. Carbon weighs only half as much as steel and is therefore the ideal material for BMW i electric vehicles which carry a large underfloor battery. The light passenger cell, made of carbon fiber reinforced plastics, compensates the battery weight completely. Less weight means greater range. In addition, CFRP is extremely rigid and corrosion-free. At the plant near the small town of Moses Lake, carbon fibers are manufactured in the quantities required for vehicle production for the first time in automotive history. The output is high-grade, fast, cost-efficient, and above all, also ecologically sustainable. This is a complicated production process in which the fibers are heated in huge ovens until they are black, strong, and light. The huge furnaces reach temperatures of up to 1,400 degrees Celsius. The fibers are spun into fine threads and rolled onto spools for shipping to Germany. The basic material required for manufacturing carbon fibers is a white polyacrylic thread, the so-called precursor.
This is the krill area. This is the first step in the carbon fiber process. In this area, we take the polyacrylonitrile and form it into a web to go into the next step of the process.
Similar fine fibers are used to manufacture knitwear, such as sweaters. In the next section, the now splayed and stretched polyacrylic strands pass through 4 oxidation ovens.
The next step in the process is oxidation. The oxidation process stabilizes and oxidizes the material in preparation for carbonization.
At temperatures exceeding 200 degrees Celsius, the fibers slowly begin to change their composition and their color. They are transformed from white to gold, to copper, to brown, to black. This process takes 1.5 hours, the details of which are confidential.
We have a very defined process recipe with time, temperature, and speed that produces a very high quality carbon fiber.
After passing through the 4 large oxidation ovens, the fibers are carbonized within a very short time inside 2 furnaces at temperatures reaching 1,400 degrees Celsius.
The next step in the process is carbonization. We have the low temp and the high temperature furnaces. This process provides the strength to the material.
The oxidation and carbonization process at these high temperatures requires large amounts of energy. 50 of the total of 80 employees supervise the immense production facility. Right from the beginning, the aim of the BMW i project was to design the entire value-added chain in a sustainable way. For this reason, the large amounts of electricity supplied to the carbon fiber plant had to be from 100% renewable sources. The solution was to use environmentally friendly hydropower. This requirement was perfectly fulfilled by the Moses Lake site. The Columbia River, located at the foot of the Cascade Mountains, holds enough water to supply more than 400 dams.
This is a fantastic place. 3 years ago, a site selection committee searched the globe for the location of our new site. We chose Moses Lake for various reasons: the exceptional workforce, land availability, and of course the main reason, the hydropower. The Columbia River Basin is the most hydroelectrically developed river system in the world. Wanapum and Priest Rapids dams provide a low-cost, renewable energy source for the Moses Lake facility that fits well with our sustainability model.
Back to production. What happens to the fibers after carbonization is a manufacturing secret.
The next step is the surface treatment. After carbonization, the material really has no functionality. It's sterile at this point. So in this process, we etch the outer skin of the material to allow it to bond with the resin system in later applications. After this, we size the material for usability and handleability. And we wind this material onto bobbins.
The carbon fiber now only weighs half as much as the precursor. With a thickness of only 0.007 millimeters, it is only 1/7 of the diameter of a human hair. The spools are ready for shipping. They weigh 9 kilograms and hold 2.7 kilometers of carbon bundles, each one consisting of 50,000 fibers. At the Bavarian town of Wackersdorf, the carbon fibers are processed into smooth lengths of material by giant sewing machines. They are placed on top of each other, overlapping in various directions, and then sewn together using plastic thread. The sheets are then cut to size, shaped, and hardened with resin. The passenger cell, made of carbon fiber reinforced plastics, is finally created in Landshut and Leipzig for the automobile of the future.